To Mrs. Riley's maths videos. Today we're doing a video on area and volume, and we're looking at prisms, not prisons but prisms. So the most nicest example of a prism is a Toblerone bar. I thought I had one in the house, but I don't, unfortunately. Toblerone bar, if you know, has a triangular shape at one end, but then it's a long solid chocolate bar. Okay, and that triangular shape is kept throughout the box. Okay, inside obviously it's divided into pieces, so it's not quite so regular, but a Toblerone box is a triangular prism. A Pringles, just to keep on the food theme, a Pringles can is also a prism. It's obviously a cylindrical prism. You know, it's a solid shape all the way through, whether it's on its side or whether it's upright or whatever. So basically a prism is any solid figure with the same cross section along its length. So I've got some here. Here's a prism. Okay, you can see this. It's solid. Okay, it's got the same cross section all along. If I was to cut a slice of this, and I was to cut a slice at the other end, or a slice in the middle, the slices would all look the same. They'd all look like this shape here, with this square with a circle cut out of it. Here's another one. These are from a marble run, so actually this has a circle in it, but we'll ignore that circle. Otherwise this is a prism. Do you see that it's solid all the way through? It has the same cross section all the way through, especially if that was filled in. Okay, this is not a prism. It's very shiny. I'll show you now, but it's not a prism, because if you notice, it changes shape. It looks a little bit like a prism from there, okay, but actually the size at this end is different to this end. Okay, so it's not a prism. It is prism-like, but because the two ends have different sizes, different areas, it is not a prism, even though it's a very nice shape. Okay, so that's not a prism. The two wooden ones were prisms. And as I say, the classic one is a Toblerone bar, or a Pringles box, which is a Toblerone bar is a triangular prism. The Pringles is obviously a cylindrical prism. So any solid figure with the same cross section along its length is a prism. Now I asked one of my sons to make this. He made this lovely triangular shape, but of course it's not a prism because it's not solid. So even though the ends are the same, and even though it carries that shape all the way along, because it's not solid, it's not a prism. But if it was solid, it would be a very nice example of a triangular prism. And here's another example of a prism. A rectangular box is obviously a prism, because again the cross section at this end continues all the way along. If I was to cut it, a slice of it at any point, it would have the same shape, would have the same cross section. Okay, so those are examples of prisms. To find the volume of a prism, what we need to do is find the area of that one end and then multiply it by the length, because basically, say the area of that end is 20 and it's a length of 10. We're saying we've got 10 slices, each with an area of 20, so 10 by 20 would be 200. So we need to find the area of one end, and then we have to multiply it by the length. Okay, so it's the area of the cross section. The cross section, remember, being the slice, the base, times the length. So it's usually the area of a base. That's normally how we work it out. Now notice this is only a prism from this angle, from this end working along here. It's not a prism from this angle, because there's that cross section. It's a rectangle, and yes, it's got that cross section on the other side. But say I was to cut it down the middle, a middle slice here, the cross section would be different. So obviously the prism, it does matter which end you take the prism from. It has to be from the end where the cross section stays constant throughout. Here's a fairly badly drawn prism, but you can see the idea. It's a triangular prism, so the cross section is a triangle. Okay, and that's the base, is a triangle. So if you remember, the area of the cross section will be the area of a triangle, which is a half times base times height. So the volume of this particular prism will be the area of this end. Let's color it this color. The area of this end multiplied by the length of the object. So in this case, it's going to be, the volume will be the area of the triangle, which is a half times base is 10 times perpendicular height is 4, which is 20 centimeters squared. I'm just putting the centimeters there, and then I multiply it by the length, so 12 by 20, which is 240 centimeters squared. So you find the area of the cross section, find the area of the cross section, and then multiply by length. Multiply by the length. Okay, let's go over the page. Here's a couple more different prisms. We've got two triangular prisms and a different prism, which is still a solid prism, but it's a different shape. So this is another triangular prism. Triangular prism. So again, if you notice here, the cross section that's going to be constant throughout the shape is this end here. So the cross section is a triangle. So it's going to be a half times base times height again, which would be a half by 8 by 7, which would be a half of 56, so 28 centimeters squared. Okay, and then I'm going to multiply that by the length. So times 9. So 9 by 28 is, I suppose I better do that in the calculator. What is it, 278 or something? 272. 9 times 28 equals 252. I'm glad I did it in the calculator. 252 centimeters squared. Okay. This next shape is an L-shaped prism. So it only works as a prism looking at it from this angle. If I looked at it from this angle, the cross section would change. So looking at it with the yellow side facing me, it's a prism. So the area of the cross section is going to be the area of that L shape. So let's see, equals area of the L shape. So I might divide that into two. So I have this part A and this part B. So the area of A, well, if this is a height of 10, then this little bit here is a height of 10. So I know it doesn't look right in the diagram, but this is actually also a height of 10 because the whole thing is 20. So the area of that, obviously I drew it badly, the area of A is going to be 10 by 10, which is 100. And then the area of B is going to be 10 by 20, which is 200. So the whole thing is 300. So the area of the base or the cross section equals 300 centimeters squared. The length of the object is, or kind of looks like almost like the depth here, the length of the object is 15. So it's going to be 15 by 300, which is 4,500 centimeters squared. Okay, cubed. Cubed obviously for volume. Okay, so the volume, I haven't actually written volume in any of these, so I'm just going back to write volume there, so we know we're talking about the volume of the prism. And then this last one here, again, it's another triangular prism. It just looks a bit weird. So this is the cross section, and it goes through there. I suppose it looks a bit like a wedge of cheese or something. So again, it's a triangular prism. So the area of the cross section is going to be a half times base times height, which equals a half times 6 times 12. That's a right angle there, I'm presuming. Half by 6 by 12, which is 36, and then multiplied by the length, multiplied by 8, and 8 by 36 is 288 centimeters cubed. Now, so the key thing to find the volume of a prism is it's the area of the cross section, whatever that is, times the length. Now that's why when we come to look at cylinder, we'll find that the volume of a cylinder, which is also a prism, so volume of a cylindrical prism, which is the volume of a cylinder, okay, is actually going to be the area of the circle times the length of the cylinder. Now, normally we call the length of the cylinder the height, and the area of a circle is pi r squared. So that's why the volume of a cylinder is pi r squared h. And we'll come to that again. Okay, bye-bye.